Alright, let's use our knowledge of what a midpoint is and what a segment bisector is to actually figure out some unknown values, kind of solve some little puzzles here. Um, and to review, a midpoint is a point which divides a line segment into equal halves. You know, here this little scenario here, I've got a line segment AC. That's all the points between and including A and C. Um, and then this ray here, BD, which has its endpoint at B. This ray is, it doesn't say on here, but I'm telling you that it's the bisector. This is just a little illustration, just to remind you of these concepts. Um, and yeah, so it's bisecting AC, which means that AB has the same length or is congruent with BC. So you can use those basic ideas to set up some problems and solve for some unknowns. So, for example, let's look at this little situation. JK, the ray, JK. So ray is something that has an endpoint and then it goes off forever in one direction. The ray, JK, bisects the line segment BO. So we got this line segment BO being bisected by JK, so that we know from here to here has the same length as from here to here. The line segment BK is congruent with the line segment KO. Okay, so BK is equal to 2x plus 3 units long. KO is equal to 4x minus 5. Find the lengths of BK and KO. Well, here's the key here. JK bisects BO. So if BK and KO have the same length, then we can set their measurements equal to each other. So BK's, I'll just write up here. BK is 2x plus 3, from here to here. And KO is 4x minus 5. And if this is truly a bisector, and then therefore if K is truly a midpoint, then 2x plus 3 must equal 4x minus 5. So we can just set that up. 2x plus 3 equals 4x minus 5. Now this might seem kind of abstract. Why would you ever need to know this or do this? You will, just kind of later. Right now you can think of it as just a little game. So yeah, so let's just solve. At this point, we're doing algebra. Back to algebra land here. So I'm probably just gonna subtract 2x from both sides just to get those x's together. So we've got 3 left on that side. 3 equals 4x minus 2x is 2x. And we've got minus 5, so I can add 5 to both sides to move that 5 over. We've got 8 equals 2x. So 2 times what is equal to 8? X equals 4. So x is 4, but the question isn't what's x. The question is what are the lengths of BK and KO. So then I could just, so I know x is 4. So BK is equal to 2x plus 3. So 2x, so x is 4, so 2 times x is 8, plus 3 is 11. And of course, since KO is congruent, it's also 11. 11, I don't know. Let's call them miles. I don't know. I didn't give any units here, so yeah, 11 units. All right, so let's try one more problem. D, E, and F are collinear, so I haven't set up a picture here, so I'm going to show you the process of setting up a picture. D, E, and F are collinear. That means they're on the same line. They're yeah, they're collinear. Share a line. The ray BE bisects DF, the line segment DF. Okay, so let's draw. Okay, so D, E, and F. So we've got, I don't know, let's say this. and we've got D, E, and F. I can't, just from this statement, D, E, and F are collinear. I can't say that D is over here and E is over here and F is over here and that they're equal spaces apart. You know, all I know is that they're on the same line. It could be FD over here and then E over here. But I know that BE bisects DF. So, so this ray, so I've got a ray that's bisecting. There's a point B here. This ray BE is bisecting DF. That's why I know that E is the midpoint. DE is equal to 5x, and EF equals 4x plus 5. Because I know that this ray is bisecting DF, I know that 5x and 4x plus 5 are equal. So set those equal to each other, solve for x, and figure out what the length of these line segments are, DE and EF, which are the equal halves of the line segment DF.